Welcome to the part 2. For measuring of the AC, we define two values of the AC. One which we are going to define and find expression for it, which is the mean value or the average value of the AC, which is defined only for one half cycle, because we already have seen that for a complete cycle its value is equal to 0. When AC flows through a circuit, AC basically produces two types of effects. One, it can deliver certain amount of the charge into the circuit. Second, it can produce the heat. So, unlike DC, which can produce heat also, which can deliver charge also, which can produce magnetic effects also, AC basically is able to produce these two types of effects. One is delivering of the charge and second one is the producing the heat. So when we define the average value of the AC, average value of the AC is defined on its effect that it is able to deliver certain amount of the charge into the circuit. In order to measure the average or the mean value of the AC, what we do, as you can see in the figure, we can define one half cycle ranging from time t equal to 0 to time t equal to t by 2 into small intervals 1, 2, 3, 4, so on up to n, such that at each interval the value of the current is I1, I2, I3, so on up to In. So the current in the interval 0 to t by 2 are divided into n parts with value I1, I2, I3, so on up to In. So the average or the mean value of the current in this interval, it can be represented as Im equal to I1 plus I2 plus I3, so on up to In divided by n. Now because we are taking the average value of all the small instantaneous values of the current from 0 to t by 2, this average current which is given by value Im, it no longer changes with the time. It no longer changes with the time, and we call this type of current as steady current, or it is also known as the DC current. Reason, it doesn't changes with the time. So because of this, the mean value is also known as the DC value of the AC. So if this current is able to deliver a certain charge Q in time t by 2 to a circuit, then using the definition of the current, Im will be equal to Q divided by t by 2, or we can write Q is equal to Im into t by 2. This is an important equation which will help us to find out the expression for the mean value of the AC. So how we define mean value of AC? It is that steady current which sends the same amount of the charge in a circuit in the same time as it is sent by the given AC current in the half of its time period. So steady mean value of the current is, AC current is that steady current which is sending same charge Q for same time in a circuit as it is sent by a given AC current in half of its time period, and it is represented by, as we have already done on the first equation, Im. Now we want to measure expression for it. We know that instantaneous value of the alternating current I is given by as I equal to I naught into sine omega t. Now if this current remains constant for a very small time interval dt, then it will be able to deliver certain charge into the circuit in the same time, which can be given as dq, it will be equal to I into dt, or it will be I naught into sine of omega t into dt. So this is the charge which is delivered by the current in time interval dt. We want to find out the charge which is delivered by this current in half cycle, that is from 0 to t by 2. So that total charge will be equal to integral of dq from 0 to q, which will be integral of I naught sine omega t dt from 0 to t by 2. I naught is constant, so we can take it outside. Integral will be only for sine omega t dt from 0 to t by 2. Integral of sine is minus cos, so it will be equal to I naught into minus cos omega t over omega 0 to t by 2. It will be equal to minus I naught over omega into cos of omega t 0 to t by 2. We know that omega is equal to 2 pi by t. So it will be minus I naught over 2 pi over t into cos of 2 pi by t into t limit 0 to t by 2. It will be minus I naught into t over 2 pi into, substituting the limit, cos of 2 pi by t into t by 2 minus cos of 0. This will be equal to minus I naught t over 2 pi into t and 2 get cancelled. We have cos pi is minus 1, so minus 1 it will be equal to minus 2, minus get cancelled, which is equal to 2 I naught t over 2 pi, which is equal to I naught t over pi. We call this as equation number 2. So if we compare equation 1 with equation 2, q is equal to im into t by 2 from the first equation, and q is also equal to I naught t over pi. So if we compare both the equations, we have im into t by 2 equal to I naught t over pi. T get cancelled and we get a value of im, which is equal to 2 by pi into I naught. This is the expression for the mean value of the alternating current over 1/2 cycle. We can also write this as im is equal to 2 over pi into I naught. Substituting the value of pi and 2 divided by pi, we get 0.637 into I naught, which says that the average value or the mean value of AC is 0.637 times, or 63.7% of its peak value. If we do the same calculation for the alternating current, we can also write that alternating EMF, it will be equal to alternating EMF average value will be 2 over pi into E naught, which will be 0.637 into E naught. Graphically, we can represent this average value on the graph as somewhere over here. If this line represents the half value of I naught, then average value will be somewhere lying over here. This will be the average value. So this will be the mean value IM. This is the I naught. Thank you.